people. So today we're going to talk about, so this is what, 131, right? And this will be a very short lesson unless I really mess this up. Um, we're going to be doing, and by the way, today's assignment, you'll have arithmetic and geometric. The only part of this lesson, the only thing this lesson pertains to is geometric sequences. Arithmetic sequences, if you haven't figured this out yet, they are downright boring. Like I add 9 each time, whoop-de-doo, or I go minus 11 each time, whoop-de-doo. Arithmetic is like a walk in the park once you get it. Geometrics can be much more tricky. So today we're going to talk about geometric sequences when R is a fractional value. And for the record, I can give you a very simple example. The examples I'm going to formally present to you, like for the 3 that I have slated for your notes, they're more challenging. They're not as observable. But for a very simple example, I would tell you, think of something like this. So if you've been here, you know this. If you haven't been, I hope you're kind of up to speed. This is obviously a geometric sequence because subtracting the same number every time obviously doesn't work, right? The first time is minus 12. The second, Trinity, would you pull our door? I don't know what is going on. I mean, really? Um, Again, you know that arithmetic won't work, right? You can clearly see that the pattern is not one of repetitive subtraction. So we immediately shift our thinking to, oh, it must be geometric. And I made reference to this before. It's going to get a little tougher today, tougher than this. But when you see this geometric sequence, what's the first thing you think is happening from term to term? Right. And that's, I would say what Trinity would say, but I also then would require us, and this is important today, you are required to think of it as multiplication by yes. And so this will be a leap for some of us, but don't worry, I'm going to show you a much, if what I'm about to say loses you, there's a bailout, the calculator bailout. But listen, the idea is I'm with Trinity initially. When I look at this, my first thought is I divided by 2. We have to train it into you that that's not allowed. When it comes to listing a formula for a sequence, R has got to be, by definition, what you're multiplying by. Okay, we don't get to fudge the formula. So in this case, we say R is equal to 1/2 because that's what we multiply by each time to get the subsequent term. So for example, like I can prove it to you, 24 times 1/2 is, look, 12. And I can go another step further and I can say, okay, look, 12 times 1/2 is, look, 6. The moral of this story here, the short story, is that when you want to say I'm dividing, you're not allowed to when it comes to writing a formula. The formula gives no hoots about division. The formula is, what are you multiplying by? What are you multiplying by? What are you multiplying by? Now, as I was explaining to someone a couple different times over the last day and a half or so, if you can't see that, like if that's not the way your brain works, if you look at 24 and 12 and 6 and you're like, I would never in a million years say to myself that R equals 1/2. The bailout, and I showed this to you yesterday, is to use your calculator. Does anyone remember the calculator method for finding R? You can pick any term in the sequence, just not the first term. And like say I picked this one, 6. And then all you have to do is divide it by the number that comes right before it, in this case, 12. Listen carefully now, because this is what we're learning today. When I take that 6 and I divide it by 12, I don't want to say 0.5. It's not technically incorrect. It's just dirty. So what we want to say is that 6 divided by 12 is a fraction that reduces to 1/2. So the next 5, 6, 8 minutes are going to be dedicated to me giving you slightly trickier geometric sequences and you and I working together to find their R values so that we can write the explicit formulas. We're going to stay with explicit formulas for at least today and probably tomorrow. Got it? Good. So here we go. That one I thought was pretty easy. So let's do this one. We can obviously agree that this thing is not arithmetic, right? If it were arithmetic, then the pattern of +2 would continue. It clearly does not. So we switch our thinking to, okay, let's see if it's geometric. Now, if it's geometric, the way to figure out the R value, again, is it can be tricky. What you want to do is take any term in the sequence and divide it by the term that comes before it. And I say this, you're not allowed to pick the first term. Sorry if this is insulting to your intelligence, but you can't pick him because there's no one in front of him to divide by. So you can pick any term in the sequence provided that it's not the first. So let's say I picked the 5. What will I divide him by? Right. Just 3. Remember, you divide by not the number that comes after. That's fatal. You divide by the number that's before it in the sequence. So if I take that second term 5 and I divide it by 3, do not actually divide on your calculator because, again, I don't want decimals. Decimals are dirty, filthy, inexact creatures. What do you see on the television? Therefore, my R value in this problem is 5/3. Which, if I were sitting in this room right now and I were still awake and I were alert and I were like really trying to learn, I would ask a very important question right now. And here would be my question. I'd raise my hand and say, Mr. Ayer, what if I had picked this red one and I had divided by this one? And I would hope that my teacher would do this. Let me show you what it looks like. Let me show you that, like I said, I won't lie to you. You can pick any term, and divide it by the term that comes right before it. So let's set up that red division problem and see if we get a match. If it doesn't match, then something has gone wrong someplace. Then it's not a geometric sequence. So here it goes. I'm going to take the term I've circled in red, and I'm going to divide it by 5. Now, let's go back to some stuff that we learned way back in the day. Your calculator will do this for you, FYI. But my goal is really to see, is the answer to this red math problem this? Let's find out. So the way we divide, remember, is yes, if you do it on a calculator, it'll do all the heavy lifting for you. But let's say I find myself, it's the old person thing to say, what if you find yourself without a calculator? Which that question is becoming more and more obsolete with every passing year, but still, let's hypothetical this thing. Haley finds herself and she's like, God, I got to do this and I just don't have my phone, or I can do this. She's going to remember some basics. She's going to remember, oh yeah, Mr. Happenschluber taught me that the first thing I have to do is make the 5 into a fraction, right? 5/1. And you guys remember the old expression copy dot flop? Yep. You remember that? So then Haley's going to be like, okay, if I have to divide 2 fractions, that means that I'm going to keep the first fraction the same, copy. I'm going to change the division to a dot for times, and I'm going to flop the second fraction over to 1/5. Remember this? It's been a minute. And then this is going to get better. Then she's going to go, oh, yeah, Mr. Floppenschlooper also taught me that I can reduce fractions like early or late. And she might go, oh, yeah, I could take this 5 and divide it by 5 and take this 25 and also divide it by 5. And then she's like, Mr. Happenschlooper also taught me that once I'm done, I can just go top times top, which is 5, bottom times bottom, which is 3. And then all is right in the world. In a true geometric sequence, you'll get the same answer to the division problem, regardless of which term you divide by the term before it. If Mr. Roscoe could find the 7th term of this sequence and she divided it by the 6th term, guarantee you she'd get 5/3. That's a true geometric sequence. Copy dot flop is generally the practice. The way my teacher said it back in the day was invert and multiply. Copy dot flop just sounds more cool. But invert means invert the second fraction and then you just create a multiplication problem. Yeah. Some people say multiply by the reciprocal. copy.plot. It just sticks. So it's still here. If your math teacher were to ask you to write the explicit formula for this sequence, we can do it. Here it goes. A sub n equals what? What goes first in our explicit formula for a geometric?
Formula.
Geometric formula. It's not a new formula. I'm just asking you to help me write the answer to this problem. So 3 goes first. And then what is after the 3? Thinking of a word that starts with D. Second letter is excuse me. The third letter is S. And it rhymes with schmistractions. Do you know the word I'm thinking of? You've already been distracted more in your 7 minutes sitting back there than you were in the previous 7 weeks sitting by me. I'm talking to Ulysses as self-control back there. I know, I get it. It's like me. If you told me I couldn't have pizza for 3 months and then you were like, here's a pizza, go slow on it, I'd have a hard time. I get it, my man.
I thought you were talking about the
I'm sorry, you don't see what I see. I was watching Captain Distraction back there. So
I was like division.
No. Dissection? Oh, he's talking to Abe. So again, our formula, which if you weren't here, the formula is this. A sub n, you don't have to write this down because you already have this in your notes. It equals a sub 1 times r to the n minus 1. Like we wrote that down like a week ago. So now that we know the formula, we're going to put 3 times, and then what's going to go in my r place? 5 over 3. And I'm just going to put n minus 1. And by the way, you're going to be doing a lot of this in Delta Math today. Delta Math is going to be heavy on type in the formula based on the sequence that you see. Okay. It'll already have this a sub n equals part. You don't have to type that. You just have to type what's in the box. So 1 down, 2 to go. Next one. Here is our sequence. Everything I'm talking to you about in this lecture is geometric, okay? Just so we're clear. Never will you see an arithmetic sequence that alternates positive, negative. It literally cannot do that because you cannot add the same number and expect to go big, small, like it doesn't work that way. So geometric, first thing I need to do. So by the way, if this were a Delta Math question, it would say, write the formula for this geometric sequence. Okay, so pick a number in the list, in the sequence. Which one do you like? I'll take the 12. And remember what I do is I got to find R, right? So right now R equals, I don't know. But to find it, I'm going to set up a division problem with the one Shariah picked, and I'm going to divide it by the one in front of it, and it's going to look like this. Again, if you put it in your calculator, it's going to tell you negative 2.5. We don't want decimals. So let's keep it in fractionville. What is 12 over negative 8? If I just reduce it like a fraction, what does it come out to? Good job. So my R value is negative 3 over 2. And I know that you trust me, so I ask questions like this, rhetorically. Do you trust me? Because you might say, I cry. No, I cry BS. Like, what if Shariah had picked the negative 18 divided by the 12? Well, look, newsflash, negative 18 over 12, divide them both by 6. Guess what? You get the same R. So we have figured out in this geometric sequence that R is equal to negative 3/2. So if I'm Aiden and I'm about to do my assignment, and this problem comes up on my screen, it says type the formula for the explicit formula for this geometric sequence. I can do this. So this is what the Delta Math box would say. It'll look like this on your screen. It'll say a sub n equals, and then there'll be a box for you to type your answer in. So here we go. What am I going to put in the box? Negative 8, because that's my a sub 1, and then I'm going to put times, and you should always use parentheses for your negative 3 over 2. Perfect. And again, the beauty of a formula, this doesn't make sense until you're ready for it to make sense. The beauty of a formula now is that Shariah could write this formula and hand it to Aubrey and say, here, go find me the 43rd term. And Aubrey's like, I got you. She just changes n into 43, types it in, she's done. Formulas are beautiful for that. You would put 43 in place of n. Micah, look up here at the TV. You put 43 in place of n. So the exponent does become 42, but we're right. You're fine, buddy. All right, one more, and then I'm going to let you. I'm going to get. Well, you'll have to give me a minute to get your assignment.
Other assignment first.
Yeah, too.
Evie.
So same instructions as the prior couple, and that is, let's see if we can write the explicit formula for the nth term of this geometric sequence. What's R? That was very quick. Good job. R is indeed 3/4. And you can't, like, it's almost like fail proof. Like, I just literally pick a number. Now listen, you'd be crazy if you picked the 9/2 in this case. Like, why'd you pick the hard one? I would pick the 6 and I would divide it by the 8. And the moment I write that, my brain goes, oh, that's just a fraction. I just reduced it to 3/4. Jackpot. All right, so help me out with this. When I'm on my delta math and it says a sub n equals big box, what is the big box going to say? 8 times 3/4 with an exponent of. Dope. So as I part ways with you here, as far as the lecture is concerned, your assignment that I'm going to create soon will have 2 parts. Part 1 is going to be a bunch of multiple choice questions just to warm you up, where it gives you 4 formulas and you pick the right one. I thought that would be a good brain warmer. And then after that, you're on your own and you write the formulas into the box. And for the record, there will be arithmetic sequences in the assignment. Let me do one of those with you real quick. My bad. If you're looking on your Chromebooks, you won't find it right now, so just hold tight. I haven't put it in there yet, so give me just another moment if you'd be so kind. Take a look up here. Do you see that? So like, let's say this pops up, and by the way, when you get to delta, it's going to go back and forth, right? Today's lesson was just about the fractional geometrics. That doesn't mean we forgot about arithmetics. If you see this, you notice that it's arithmetic right away. Why? What triggers that? Because it goes up by 4 each time. -10 plus 4 goes up to -6. -6 plus 4 goes up to -2. I can see that that's consistent addition by the same number. So I immediately go to my arithmetic way of thinking. So remember, we don't say R anymore. We say D. And what is D in this sequence? It is 4. Yeah, it stands for difference, right? Good job. And so the difference, or the D in this value, in this sequence, is 4. So if it said to you, so here we are, we're in delta math. Here's my box. I'm just doing fake delta math here. I'm doing Ahern math. What would I type in for the formula? -10. Now it's arithmetic, so we play. Good job, senora. Remember, it's plus when we do arithmetic.
No, plus the number we need to know.
Plus. Nope, not this. We're just doing a formula. So in this case, guys, you're just going to put n minus 1. And then at the end of it, we're going to put times 4. So that's what you'll type in today. And again, what's confusing is like, you're like, well, I need to know the number. And actually, no, you don't. We're just writing formulas here. And if I said Shariah now, just for shiggles, find me the 37th term, she could put 37. But like, that's not what we're practicing today. We're practicing just writing the formulas today. So got it? Right, I'm going to end recording, and if you give me just a couple minutes, I'm going to fire up. I had the assignment ready, and then I something. Never mind.